Okay, folks, we are on to our next law of exponents, which is division. So we have two rules that we'll learn today. And we'll see what happens when you have exponents when you're dividing. So we're going to kind of start off with a little exploration to kind of help us understand what happens. So it says, use the example 2 to the 5th over 2 to the 3rd. Now remember, this bar there means to divide. It's a fraction bar. It is simply dividing. So it says expand using the definition of exponents. So how many 2's will I have on top? Well, I should have 5. So I'm going to have 2 times 2 times 2 times 2 times 2 all over 2 to the 3rd. So we should have 3 2's on the bottom. So 1, 2, 3. So that is what it would look like if we wrote it in expanded form. What would cancel? Write your answer as a single exponent. So if I look here, do you guys see how those two 2's would cancel out with each other? These two 2's would cancel out with each other, and those two 2's would cancel out with each other. So we're simply just left with 2 times 2, or 2 squared on the top over 1, which we just know is 2 squared. Okay, let's try again with another example. We'll see if we have a pattern. Repeat using x to the 9th over x cubed. So I'm going to have 9 x's on top. 3, 4, 5, 6, 7, 8, 9. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So x to the 9th over x to the 3rd. Okay? So again, what cancels? Those two x's cancel with each other. These two x's cancel with each other, and those two x's cancel with each other. So how many x's are we left with on the top? 1, 2, 3, 4, 5, 6. X to the 6th over what? Well, nothing, so really over 1, which we just know is x to the 6th. So what do we notice? Well, if you guys look here, is there a relationship that exists between 9 and 3 and 6? I hope you're thinking you're subtracted, right? 9 minus 3 is 6. Or if we look up here, with this example, 5 and 3, and then I have 2. Well, 5 minus 3 is 2. So the pattern when you divide exponents with the same base is subtract your exponents. Okay, so that's our first rule today. So when we're dividing powers with the same base, subtract your exponents. Okay, so these first ones are pretty straightforward. So 7 over 5 over 7 squared. So I have the same base, 5 minus 2 is 3. So 7 cubed. And we're done. Same thing here, we have the same base, 5 squared over 5 to the 5th. So I'm going to have 5. 2 minus 5 is negative 3. Do we want a negative exponent? Nope. So we rewrite it as 1 over 5 cubed. All right, let's try some p's here. Same base, so I have p. 7 minus 10 is negative 3. We know we don't like negative exponents, so I'm going to put it under 1. 1 over p cubed. So now we're just going to kind of get more complicated as we go, okay? The idea is still the same. We just have multiple things happening at once. So just focus in on your k's on this one. I have 6 k's here and an imaginary 1 there. So 6 minus 1 is 5. And then I look at my j's. I have 2 minus 5, which is negative 3. And now we just make that answer have no negative exponents. So I'm going to bring that j down. So the k gets to stay on top, and the j has to come down. So k to the 5th over j cubed. And I'm sorry that my smartboard isn't acting quite right. I can see if I can try to fix it here quick. Give it a second. There we go. Okay, so that should be better moving forward. All right, let's try some more of those weird ones, all right? So again, we're just taking it piece by piece. So kind of block out these b's. So right now I just have a to the negative third over a to the fifth. So how many a's will I have? Well, what's negative 3 minus 5? And if you don't know, use your calculator. Negative 3 minus 5 is negative 8. Now we gotta look at our b's, so cross off those a's if that helps you. Block them out with your hand. Now if I look at my b's, I have 7 over 2, so 7 minus 2 is 5. And now we have to rewrite it with positive exponents. So if I put this over 1, our a has to move, because it has to go to the bottom to become positive, and the b gets to stay on top. That's our answer. Okay, let's try another one. Again, just pick it apart piece by piece. So I'm going to blur out my y's and z's. I'm just going to look at my x's. So I have x to the fourth over x to the fourth. Well, let's look at it. So we're going to have x. What's 4 minus 4? 0. So I have x to the 0. Now I'm going to look at my y's. So I'm going to cross off my x's. So I have y to the negative 1 over y to the negative 5. So negative 1 minus negative 5. If you don't know, use your calculator. Negative 1 minus negative 5 should be 4. Okay, keep moving along. Look at our z's. I'm going to block out now my y's and my x's. Z to the 8th over z to the imaginary 1. 8 minus 1 is 7. So now we can actually make this answer a little bit nicer. X to the 0 we know is just really 1. So we could write y to the 4th, z to the 7th. You could put this one in front, but really it doesn't matter because it's already imaginarily there. So really this is our answer. So I challenge you to maybe pause the video and see if you could do this example on your own. I know it's kind of a doozy, but if you just pick it apart piece by piece, I think you would do just fine. Then you should pause the video and try it right now and then compare your answer with what I get. But I'm going to go ahead and do it right now. So I'm going to start by crossing off all this extra stuff. I'm just going to focus in on my numbers. So this means 18 divided by 6. What is 18 divided by 6? You should be thinking 3. Okay, so I have 3. And now I'm going to focus in on my x's. So I'm going to cross off my numbers, get rid of my y's and my z's. So I have x to the negative 6 over x squared. Well, negative 6 minus 2 is negative 8. Again, use that calculator if you're not very good at subtracting positive and negatives. There's no shame in that. Now I'm going to cross off my x's and my z's and just focus in on my y's. So I have y cubed over y to the negative 2. Well, 3 minus negative 2 is really 5. And again, with our last one here, just focus in on the z's. Negative 3 to z to the 5th. Negative 3 minus 5 is z to the negative 8. All right. So remember, folks, this is really over 1. So I got to rewrite it with positive exponents. So there's my fraction bar. Now let's just start with the 3. Does a 3 have a negative exponent? Nope, so it gets to stay. What about our x? It does have a negative exponent, so that has to come down. Y to the 5th gets to stay. Z to the negative 8th does have that negative exponent, so it has to come down as well. So this should be your final answer. So big takeaway there, you guys, is when you have bases the same, you subtract your exponents. All right, we're going to take it one step further on the next page. What do you do when you have a fraction raised to a power. So we call this raising a quotient to a power. Now, when this happens, you have to distribute your power to both whatever's on the top and whatever's to the bottom. So that's how you get a to the nth over b to the nth. You distribute that power to your a and to the numerator and denominator. Okay? So now these are going to get pretty crazy, all right? So just kind of buckle up and absorb as much as you can. So I think it helps if you draw in your little lines there so you can kind of remember what you're doing, all right? So if we just focus in on our numerator here, I'm going to go like whoop and like whoop. So you could write this as w to the 5th cubed all over 4 cubed. That's how it would look right away. Now this is a review of yesterday. When you have a power on a power, do you guys remember what you do to your 5 and 3? You multiply. Yep, you multiply. So 5 times 3 is 15. All over 4 cubed. Well, you could put 4 cubed, but you can actually figure out what that number is. So in your calculator, figure out what 4 to the power of 3 is. And you should be getting 64. So that is your final answer on that one. All right, let's try another one. So again, draw in your little rainbows, loop-de-loos, whatever you want to call them. So on the numerator, I'm going to get 3 cubed all over 4 squared to the power of 3. And now we're going to simplify. Okay, you guys, in your calculator, figure out what 3 to the power of 3 is. You get 27. 3 times 3 times 3. And now on this one, we have 4 squared to the power of 3. So remember, you have to multiply 2 times 3. So 2 times 3 is 6. So I have 4 to the 6. And now let's figure out what 4 to the 6 is. 4 times 4 times 4 times 4 times 4 times 4, or 4 to the power of 6. It's 4,096. So that should be your final answer on this one. All right, are you guys with me? Let's try another one. So again, we're going to distribute that power to both the top and bottom, the numerator and denominator. So we're going to have 5 squared to the power of 2 over 5 to the 4th squared. All right, so on the top, how many 5s will we have? Well, 2 times 2 is 4, so we're going to have 5 to the 4th over 4 times 2 down here would be 8. Well, now we have a problem like we had on the first page of our notes. So I'm going to subtract my exponents. So 4 minus 8 equals 5 to the negative 4th. And we know we can't have a negative exponent, so we're going to put it under 1. And then really, you guys, we could take this one step further. What is 5 to the 4th power? 625. So really, your final answer on this one should be 1 over 625. That should be your final answer on this one. And you guys, I get it. This is a lot of information. It's all new, and it's complicated stuff. So if you're feeling kind of overwhelmed right now, know that that's normal. And we will be on this for the next while until we're really comfortable with it, okay? All right, here we go. Let's try another one. Remember, distribute to the top and bottom. So I'm going to have 3 to the negative 2 over 5 to the negative 2. We know we don't want a negative exponent, so my 3 has to come down, and my 5 has to come up. And now we just evaluate. 5 times 5 is 25. 3 times 3 is 9. There we go. Okay, here we are, folks. Let's see what we can do. Again, when you have a fraction or quotient is what this is called, to a power, you have to distribute that to absolutely everything you see in there. So I'm going to have 4 to the power of 3 x. Now, can we maybe simplify the step? What's 4 times 3? 12. Yep, it should be 12 all over 8 cubed. All right, now we're going to simplify. What's 4 to the power of 3? That's 64 over x to the 12th. And then 8 to the power of 3, guys. 8 times 8 times 8 should be 512. That should be your final answer. All right, let's do another one. Distribute that negative 3 to everything you see. So I'm going to have 2 to the negative 3 x. Remember, a power on a power, we multiply. So what's 6 times negative 3? Negative 18 all over y. 4 to the times negative 3 should be negative 12. And now we have to make this without negative exponents. So I know my 2 has to come down, so 2 to the third. My x has to come down to make that a positive 18. And the y to the 12th comes up. And folks, really, we can take it one more step, because what is 2 to the power of 3? That's 8. Yep, it is 8. So now this would be your final answer. All right, let's try another one. Again, distribute negative 2 to everything you see. So on the top, we're going to have a to the negative 2. On the denominator, 5 to the negative 2, and b to the negative 2. Now we have to make everything with a positive exponent. Where does your a have to go? Well, it has to come down to become positive. Our 5 has to come up, and so does our b. But we can figure out what is 5 squared, you guys. 5 times 5 is 25. So we have 25b squared all over a squared. I challenge you right now to try this one. And you should pause the video, distribute that negative 2 to everything you see, like this, and to the 2 on the bottom, and see what you get. All right, I'm going to go ahead and do it. I hope you tried it. So a negative 2, or not, negative 9 to the power of negative 2, x. 4 times negative 2 is negative 8, all over 7 to the negative 2, and then y. 3 times negative 2 is negative 6. Let's make all those exponents positive. So the 9 has to come down to the negative 9 squared. X to the negative 8 comes down, so it's now positive 8. 7 squared comes to the top, and y to the 6 comes to the top. And now we just have to evaluate, what is 7 squared? Well, 7 times 7 is 49. Y to the 6th, all over negative 9 times negative 9 is 81. X to the 8th. Okay, on this one, what I would do, actually no, let's just do it the same way. Okay, distribute that negative 4 to everything you see. So we're going to have y, 7 times negative 4 is negative 28. All over y, 10 times negative 4 is negative 40. Now, when we have same base and we're dividing, guys, you just subtract. So negative 28 minus negative 40 should be 12. It's a positive 12. So y to the 12. That's it. Then we end with a nice easy one. Anything to the 0 power, doesn't matter what's inside this, as long as it's to the 0 power, we know it's just 1. Whew, I know that was a lot. Thank you for watching. Show me that you've completed your notes, and I will get you your homework.